Welcome. In this video we finish section 2.3 on lines. We will take a look at the last three objectives. We will look at lines using the general form of the equation. We will look at parallel lines, and we will look at perpendicular lines. So let's talk about the general form equation of a line. We've seen two forms already. We've seen the point-slope form, where I can draw out the point that a line goes through and its slope. So for example, in this line I can tell that it goes through the point 3, 2, and it has slope 5. And we've looked at the slope-intercept form, and so from this form I can pull out the slope. I see that the slope is 1/3, and I can see that the y-intercept is 9. But there's another form called the general form, and that is just like 3x plus 2y equals 12. It's just a number times x plus a number times y equals 12. Sometimes you see it ax plus by equals c. Whenever your line has an equation in this form, this is the general form. Unfortunately, with the general form, you can't pull out the slope or a point so easily, but there is one nice feature to the general form. And that is, the general form is great for finding intercepts. So the y-intercept and the x-intercept. How do we do this? So here's a line given to us in general form. Find the x-intercept. Here's the trick. To find the x-intercept, I set y equal to 0. So if y equals 0, so 2 times 0, this whole equation becomes 3x equals 12. And now I can divide both sides by 3 and get x equals 4. So there's an intercept on the right, so on the graph I can plot the point at 4. Now let's look at the y-intercept. How do I find the y-intercept? I will set x equal to 0. So if x equals 0, then that first term goes away, and all I'm left with is 2y equals 12. And if I divide both sides by 2, I get y equals 6. So I'll plot that. It looks like I need to extend my y-axis a little bit. I'll plot 0.6. And now that you have an x-intercept and a y-intercept, you can graph the line that goes between those 2 points. Let's do one more example. Consider this equation of a line 2x minus 4y equals -8. Go ahead and pause the video for a second, try to find the x-intercept and the y-intercept, and then unpause when you are ready to check your work. Alright, I will do this now. How about the x-intercept? I'm going to make y equal to 0, which eliminates that term, so I get 2x equals -8. Divide both sides by 2, x equals -4. I will plot the -4 on the graph. For the y-intercept, I will set x equal to 0, which means -4y equals -8. Divide both sides by -4, and I get y equals +2. Y equals +2, plot that point, and now you can graph the line that goes between those 2 points. Alright, let's find the slope and y-intercept of these two lines. These two lines are both given to us in the general form equation. How do I find slope and y-intercept if I want to? And it really boils down to solving for y. So solve for y. And if I can do that, then that puts the equation into slope-intercept form. Let's see what I mean. So in this first example, maybe I will subtract x from both sides. So this becomes 2y equals, I'll be clever, I'll put the -x out in front, plus 8. And then divide both sides by 2. So 2 over 2. Now, what I get on the left is y. What I get on the right is, look how I can split a denominator between two terms. I get -x over 2 plus 8 over 2. And one more simplification, this -x over 2, that's the same thing as -1/2 x, and this 8 over 2 is the same as 4. And so I've been able to put the equation into slope-intercept form. I see that my slope is -1/2, slope negative 1/2, and I see that the y-intercept is 4. One thing I could have done at this step here, instead of dividing both sides by 2, I could have thought about multiplying both sides by 1/2. Look how that works. 1/2 times 2y equals 1/2 times negative x plus 8. And then you can distribute the 1/2 on the right, and you get negative 1/2 x plus 4. So that might be another way to solve this problem. Instead of dividing both sides by 2, think of it as multiplying both sides by 1/2. All right, let's take a look at the equation on the right. To solve for y, I will subtract 7x from both sides, and we get negative 7y equals negative 7x. Oh, let's divide both sides by negative 7 to get rid of that negative 7 in front of the y. And I end up with y equals x. Well, what is the slope and y-intercept for this line? Well, this is kind of like y equals 1x plus 0. I'll write this down. Y equals 1x plus 0. So my slope is 1, and my y-intercept is 0. So this is really just the line that goes right through the origin with a slope of 1. Let's turn our attention to parallel lines. Parallel lines are pretty straightforward. If two lines have the same slope, they are parallel. This is what distinguishes parallel lines. Parallel lines have the same slope. This line on the left has a slope of 2. The line on the right has a slope of 2. They have different y-intercepts, but they are parallel because they have the same slope. How would you show that these two lines are parallel? Really, it boils down to showing that they have the same slope. So let's find the slope of each. And to do that, we solve for y. On the left, let's see here, I'll subtract 2x from both sides, so I get negative y equals negative 2x plus 8. I will negate both sides, so y equals 2x minus 8, and from here I can pull out the slope. So it looks like my slope is 2. How about on the right? I need to solve for y, so I will add x to both sides. 1/2 y equals x plus 1. Multiply both sides by 2. Y equals 2x plus 2. And look at that. Slope is 2. So they actually do have the same slope, so they are parallel. Check. Sometimes you see a problem like this. Find an equation for a line parallel to some given line that passes through some given point. To make an equation for a line, I need two pieces of information. I need a slope and a point. So from the line that's already given here, that line has slope 4. So I need to create my own line that has slope 4, but passes through the point negative 1, 7. So this is my x1 and y1. So the point slope formula for the line, y minus y1 equals m, x minus x1. Let's fill in the information. Y minus 7 equals, now I draw the slope from the other line, 4, x minus, and my x1 is negative 1. So just to clean that up a little bit, y minus 7 equals 4 times the quantity x plus 1, and there is my line. It asked for an equation, so any equation would do, and there's the one that I found. There's my point slope formula for the line. Let's talk about perpendicular lines. This is really interesting. It's not tricky, but it's just kind of curious. If two lines have slopes that are negative reciprocals of each other, then the lines are perpendicular. Here are some examples of numbers that are negative reciprocals. So 2 and negative 1/2. Those are negative reciprocals. 3/4 and negative 4/3. Negative reciprocals. Negative 5 and 1/5. In general, negative reciprocals look like this. If your slope of one line is a over b, then I will take the reciprocal of that, b over a, and negate it. So these two numbers, a over b and negative b over a, those are negative reciprocals. Let's take a look at this first example. 2 and -1/2. So I have a line here with slope 2, and I have a line with slope -1/2. And yeah, you can see it looks like those two lines are perpendicular. The second example, 3/4 and -4/3. Those are those two lines. Maybe you can confirm, pause the video and confirm that those really are the slopes. Let's see, I have a few lattice points in here I can pull out. And the third example, -5 and +1/5. So the very steep line has slope -5, and the shallow line has slope 1/5. And those are perpendicular. Here's a problem you might encounter that involves perpendicular lines. You're given two equations, and you want to show that the two lines are perpendicular. Well, it really boils down to just finding the slopes of the two lines. In the first case, I see that the equation is already in slope-intercept form, so I can pull out the slope right away. It looks like the slope is -1/2. So in this equation on the right, can you tell what is the slope I hope to end up with? I'm thinking in the back of my mind that maybe the slope of that other line is 2. Let's see. So I need to solve for y. I will subtract x from both sides. I get -1/2 y equals -x plus 2. How about if I negate both sides? So 1/2 y equals +x minus 2. And then multiply both sides by 2. And that gives me y equals 2x minus 4. I know I'm going pretty fast through these steps, so for your own personal work, take the time that you need in order to make sure that the equations work out. Alright, now I have solved for y, and I can see that the coefficient on x is 2, so look at that, the slope of this line is 2. Yep, the slope of the first one was -1/2, the slope of the second one was 2, so yes, indeed, these two lines are perpendicular. Now let's do the problem where we're given a point that my line has to go through, but I want to make a line that is perpendicular to this given line. Alright, so I need to find the slope of the given line, then take its negative reciprocal, that's going to be the slope I want, and then make a line that goes through the point with that new slope. Alright, let's give it a try. So how about, let's figure out the slope of the line that was given to us. 3x plus 2y equals 6. Solve for y, so I'll subtract 3x from both sides. 2y equals -3x plus 6. Divide both sides by 2. Y equals -3/2 x plus 3. And I see the slope. The slope of this line is -3/2. So for me, at the line that I'm creating, I want a slope. See, I want a slope of 2/3. Alright, so let's make my line. I need the slope-intercept form. Y minus y1 equals m x minus x1. So what is my y1? My y1 is -1. Y minus -1 equals, now the slope I'm going to create is the 2/3. X minus, and my x1 was 5. And then just a little tidying up. We'll make that minus a -1 into a +1. And I think that's it. 2/3 x minus 5. And we're done. I have found an equation. What about these pairs of lines? Can I tell if these pairs of lines are parallel? Are they perpendicular? Are they neither? Take a look at the first two. This first line has slope 3. How about that second line? Oh, that has slope -3. Are these parallel? Perpendicular? Neither? They're neither. They're not the same slope. If they were exactly the same, they would be parallel. And they're not quite negative reciprocals of each other. They're only negatives. How about this second case? I need to find slopes, so how about if I solve for y? I'll label these A and B. So equation A, when I solve for y, I get y equals negative 5x plus 12. And equation B, when I solve for y, y equals negative 5x minus 1/12. Now, they tried to trick us, right? There's a 12 and a negative 1/12, but that doesn't matter at all. The only thing that matters is the coefficient in front of the x. That tells us the slope. And so, it looks like both of these have slope negative 5. These are parallel. All right. So that finishes this little section where we talked about the general form of the equation for a line, and we talked about some parallel lines and perpendicular lines. And this actually finishes section 2.3 on lines.